Hey, so today we're going to talk about angles of polygons, and we're starting to get into what most people recognize as geometry because it's involving shapes. We're going to be talking a lot about angles as well, so it really connects back to the last couple lessons. The sum of the angles in any triangle is blank. Use that information to find the sum of the angles in each of the polygons below by dividing each polygon into triangles. So we need to know that a triangle is made up of 180 degrees. Every triangle, no matter how big or small. In order to then use this information, a 180-degree triangle is going to be made by splitting up the other shapes. So you'll notice that this quadrilateral can be split into two triangles. So this triangle has 180 degrees and this triangle has 180 degrees, meaning that the quadrilateral has 360 degrees in it total. This pentagon, if we divide it up into triangles, has three triangles, 180 degrees, 180 degrees, and 180 degrees, meaning that a pentagon is made up of 540 degrees inside. You can continue to do this for each shape. You'll notice that each time I add a new side, I'm adding a new triangle. So for example, 1, 2, 3, 4, 5, 6. This hexagon with 6 sides has 1, 2, 3, 4 180-degree triangles inside it, meaning that it is made up of 720 degrees. And it would make sense then that this 7-sided shape would be made up of 5 triangles, each 180 degrees, or let's say 7 sides, 5 triangles. It has 180 degrees times the 5 triangles, making it 900 degrees total. And that would work for any of these. This 5-sided has 3 triangles. This 6-sided has 4 triangles. So the number of sides we're going to represent by the letter N. So quadrilateral has 4 sides, pentagon has 5 sides, hexagon with 6 sides, and heptagon with 7 sides. Number of triangles. Okay, so a triangle has 1 triangle in it. The quadrilateral had 2 triangles. The pentagon had 3 triangles. The hexagon had 4 triangles. And the heptagon had 5 triangles. Each one of those triangles consisting of 180 degrees. So the 2 triangles in the quadrilateral times 180 made it 360 degrees total. The 3 triangles in the pentagon times 180 made it 540 degrees total. The 4 triangles in the hexagon, 180 degrees each, made it 720 degrees in the hexagon. And 5 triangles at 180 degrees each made the heptagon 900 degrees. How much does the sum of the angle measures increase from a 4-sided to a 5-sided polygon? So we said every time you add a new side from 4-sided to 5-sided, you add a new triangle, which means you also add a new 180 degrees. So it's a 180-degree increase for each new side. How is the number of sides of the polygon related to the number of triangles? So you'll notice 4 sides, 2 triangles, 5 sides, 3 triangles, 6 sides, 4 triangles, 7 sides, 5 triangles. The number of triangles is always 2 less than the number of sides. So n minus 2 equals the number of triangles. So if number of sides is n, number of triangles is n minus 2. Write the formula for finding the sum of the angle measures of any polygon. Use S equals sum of the angle measures. So in order to get S, the sum of the angle measures, we have to find out how many triangles are inside. So n minus 2 is the number of triangles, right? We just did that on the table on the front. Each triangle worth 180 degrees. So we normally will do 180 times n minus 2. You'll notice I put the n minus 2 in parentheses because we need that number first, how many triangles, and then we multiply it by 180. And that would be equal to S, the sum of the angle measures. So using that formula, in number 5, the formula we just created to find the sum of the angle measures of a nonagon. Now, a nonagon is a 9-sided polygon. And instead of drawing it, or instead of, making all the little triangles inside, we're going to use n equals 9. So S equals 180 times n minus 2. That's the equation we just created in order to get the sum of all the angles, we're going to do 180 times 9 minus 2. A 9-sided shape would have 7 triangles in it. Each triangle times 180 degrees makes it 1,260 degrees in the nonagon. So the sum of the angles would be 1,260 degrees. And don't forget that degree symbol. And there we go. Use your formula in number 5 to find the measure of one interior angle if it's a regular octagon. Now, first of all, an octagon is an 8-sided figure or 8-sided polygon, which means n equals 8. It also says that it's regular. Regular means that all sides and angles are congruent. So if we know how many degrees in the whole shape, we can then divide by 8 to find out how many degrees are in just one angle. So S equals 180 times n minus 2. I am going to use 8 for number of sides because it's an octagon. I am going to do 180 times. Now, 8 sides means that it has 8 sides means that it has 6 triangles inside. 8 minus 2 is 6. And the sum of all the angles is 1,080 degrees. That is for the whole octagon. Well, if that's how many degrees are in the whole octagon, we're going to do 1,080 divided by 8 to get how many degrees are in just one angle. So each angle is 135 degrees. So if you want to test me on that, 135 degrees times 8 is 1,080 degrees for the whole octagon. We can also use our formula to find the value of a missing angle. If something we have is like this, where it's not regular, we would need the 3 other angles in order to find a missing one. So we'll start with the fact that this 1, 2, 3, 4 is a quadrilateral. So I would say S equals 180 times n minus 2. I'm using my formula. My n in this case is 4. The sum of the angles is 180 times the fact that there would be 2 triangles in a quadrilateral. And that means 360 degrees. Now, this might be a fact that you know. You might know that a quadrilateral has 360 degrees. But for the most part, we'll have to do that piece of solving in the beginning. Now, in this shape, we have a 90-degree angle. That's the one with the little square in the corner. Plus, we have a 125-degree angle. Plus, we have a 60-degree angle. Those are all the angles that we know. Plus, there is a 4th angle that is labeled x degrees, which is the one we're solving for. If we add up all 4 of them, we know they need to add up to 360 degrees. So the 3 angles we know take up the first 275 degrees of this quadrilateral. And we have 360 to work with. We're going to take away that 275 from both sides, and we're going to get that the missing angle, x, has to be worth the missing or the remaining 85 degrees. And we don't want to do that visually. We don't want to pull out a protractor. Most of the time when you do these problems, they are not drawn to scale. They're checking to see whether you know how to do algebra versus guessing or measuring, which would be a lower level skill than an MSM3 skill. So we'll do several of these practice ones, and it's not going away. We'll be working with geometry for a little while. So we'll see you soon.